All right, 11.3, using normal distribution. Can I move on to the next slide? So I would take a second and copy this definition down. I will show you the curve on the next page, so you don't necessarily have to copy it down from this page. But a normal distribution is modeled by a bell-shaped curve called a normal curve. Okay, so this curve right here is a normal curve that is symmetric about the mean. Symmetric means I've got as many data points on the left as I have on the right. First of all, notice the fancy yellow box up there that says find this first. You should find the z-score first. In all the problems, well, most of the problems today, we're going to find the z-score first. That gives us information. Okay, the z-score. If you look right here, the z-score is the x value minus, what does that x bar mean? Minus the mean divided by this lowercase sigma, which remember means the standard deviation. Okay, so the z-score is the number of standard deviations away from the mean. The number of standard deviations away from the mean. Round it to the nearest tenth. So when you find the z-score, round to the nearest tenth. Okay, so you notice these percentages over here on the left. Okay, let's look at the first one. It says 68% of the data falls within one standard deviation. So this right here says 68% falls within one standard deviation of the mean. That means if we look to one standard deviation to the left of the mean, that'd be this area in here, and one standard deviation to the right of the mean would be this area in here. That totally encompasses 68% of the data. 68% of all the data points are going to fall in that first range between one standard deviation or plus or minus one standard deviation. As we move out further, if 95% of our data is going to fall within two standard deviations. All right, so within two standard deviations, we are going to get almost all of our data, save for 5%, but we're going to get almost all of it in two standard deviations. That means if I go plus 2 standard deviations or minus 2 from the mean, then I'm going to end up with 95% of the data. And then finally, if I go 3 standard deviations, I almost have everything. So that includes almost everything. And you will never go past 4 standard deviations. So keep that in mind. You'll never go past 4 standard deviations. Okay, moving on. Okay, so this is just copied down. Whoa. This diagram up here is just copied down, so you don't need to recopy that. So let's look at this problem. A normal distribution has a mean of 27 and a standard deviation of 5. Find the probability that a randomly selected x value is at most 32. So in this problem, there's some important things. The first thing is normal distribution. That tells me that I'm thinking about a normal curve. Okay? Curve that's symmetric, a normal distribution. Okay? Pretty much everything we deal with today will be normally distributed. So you won't have to worry too much about that, but it does have meaning. Okay? Then I tell you this data has a mean of 27 and a standard deviation of 5. Find the probability that that value is at most 32. So we need to think about what at most means, Caitlin. The very first thing that we're going to do is find the z-score. Okay, so the z-score. Whoa. The z-score. And we said that was x minus the mean. All right, well, what is x in this problem?
32.
It's 32. Okay. So it's 32 minus 27 divided by 5. What do you get? Isn't that just 5 over 5?
Yeah, so it'd be 1.
Which is just 1. All right. If you get a z-score of 1, here's how we're going to approach the problem. So you might star this or highlight or something to indicate that z-score of 1, we take this approach. If the z-score is 1, and I want to know that the probability that I randomly selected x value that is at most 32. That means at most 32 means I don't want to go any higher than 32. So if I'm thinking about what regions I'm looking for, what kind of areas under the curve I'm looking for everything behind 32. So what is the probability that I randomly pick a data point, all my data, and it falls at 32 or lower? Well, that's just going to be the area, or each individual area added up. Okay? And I think, since the z-score is 1, we can just use this, the curve that we looked at earlier, the standard normal curve to help us out. Okay, so to find the probability, we would say that x is less than or equal to 32. That's going to just equal all those probabilities added together. So we'll take 34 plus 34 plus 13.5 plus 2.35 plus 0.15. And what do you get? 84. So the probability is 84%. There's an 84% chance that that value is at most 32. And so write this down. At most means less than or equal to. At least means greater than or equal to. Okay, so now you guys have this table. I would use it as a bookmark. This is a table of z-scores and probabilities. In the gray, so in the gray up here, these are how we find our z-scores. Notice the z up there in the upper left-hand corner. In the white, come on. In the white, these are all probabilities. Okay, so in the white are probabilities. Whoa, that's a little spacey. Is that this works, we can kind of use it in its normal fashion if the probability is less than or equal to. Okay, so you'll see what that means in the next slide. But you want to highlight that or maybe even write it on that table. The probability is less than or equal to, we can use the table normally. If it's not, then we gotta kind of use a trick or two. Negative 2.9. So the z-score is negative 2.9. I want to figure out what that probability is. I'm going to go to negative 2 on the left-hand column. Negative 2 is right there. All right, I'm going to go to negative 2. And it's negative 2.9. So I don't want 0.1. I don't want 0.2. I'm going to go all the way over to 0.9 and find that probability. So that probability is going to be negative 2.9. I think it's going to be right here. Okay. So for that z-score, the probability equals 0.0019. Z equals 0.6. All right, well, that's a positive 0. Right? So I'm going to go to that positive 0. Can you guys... Uh-oh. What happened? You guys see that? Okay. Positive 0. And 0.6. So that's all the way over to 0.6. So what's my value there for the probability then? P equals 0.7257. Okay. So why would I ever use a negative 0? So negative zeros would be for a negative decimal, like if we had negative 0.3. And z equals 1.6, we'd go to 1 and to 0.6. So we're looking at 0.9452. P equals 0.9452. All right. Suppose we have a normal distribution with a mean of 75 and a standard deviation of 10. I want to find the indicated probability. So for this first example, I want to find the probability that x is less than or equal to 70, when my mean is 75 and my standard deviation is 10. I'll give you a second to write that down, and then we'll do it. We'll use the table to solve it. So let's go find the z-score first. Z equals whatever our x value is. Well, that's 70 in this example. Our given x is 70. 70 minus 75. The order is really important because remember, there's a difference between a negative z-score and a positive z-score. So 70 minus 75 divided by my standard deviation, which was 10, gives me a z-score of what? Don't use your calculator. 5 over 10, negative 0.5, right? Okay, so if I'm looking for a z-score of negative 0.5 and I want to know the probability, then I'm going to go to the negative 0, right here. I'm going to go over to 0.5. So over to 0.5 is going to put me right here, okay? So my probability that x is less than or equal to 70, probability that actually happens is 0.3085. 0.3085. This is the exact same data as before. I've got a mean of 75 and standard deviation of 10. Don't recopy that down. The only thing that's changed is now I want to know the probability that x is greater than or equal to 82. So this is the difference. All right? Gosh darn it. The probability is greater than or equal to 82. So to find it if it's greater than or equal to, find the z-score, look up the probability, and find the complement, or 1 minus the probability. So before you write anything down, stop writing. Think about the normal curve here. I know, that's a good normal curve. Before, in one of our examples earlier, we said, hey, what is the probability that you kind of land over here in the yellow area, right? And that was a less than or equal to example. If we wanted greater than or equal to this line, couldn't we just take 1 minus the yellow area? Okay. Wouldn't that give us the area in blue here? Okay, so if I wanted to, oh, this would be good. If I wanted the area in blue, the blue shaded area equals 1 minus the yellow shaded area. First thing we do is find the z-score for 82. So z equals 82 minus 75 divided by 10. What do you get, 0.7?
Yes.
Okay. So we get 0.7 for our z-score. And so I go to my table and I look at 0, positive 0, over to 0.7. Right there. So my probability is 0.7580. But that's less than or equal to 82. I want greater than or equal to 82. So the probability that x is greater than or equal to 82 is going to be 1 minus this. Oh no. Is going to be 1 minus this 0.7580. 0.7580. What do I get for that probability? 0.2. Are we sure?
No.
242.
Dang. Nice word.
We got to find each z-score. So let's find for 60 first. Let's do that first. 60 minus 75. Notice the data is the same, so don't recopy the data. Divided by 10, and I think I get negative 1.5. Is that right?
Yep.
Okay. Let's rewrite that. Negative 1.5. Okay. Let's find the next z-score. So for the last data point, it's 70 minus 75 divided by 10, which is what we already figured out, negative 0.5. I think we already did that one. Okay. So these. So for negative 1.5, the probability negative, 1.5. So I'm going to go to negative 1 over to 0.5, 0.0668. Let's do the next one. For negative 0.5, I think we already figured out that P was what? 0.3085. 0.3085. Okay? So, that gives me the probability of each one. And then the last thing it says is now subtract the highest probability from the lowest probability. So, in a kind of our final statement here, we're going to say the probability that x is somewhere between 60 and 70 is going to equal the highest probability, I think, is 0.3, right? That's greater than 0.066. So I'm going to take 0.3085 and minus 0.0668. And I'm going to run into the watermark, so we'll move up. And then what do I get for that when you actually do that subtraction? What do you get? 0.2417. So 0.2417 is the probability that I'd land somewhere between 60 and 70.